Well, today's video is on thin layer chromatography. Thin layer chromatography is a very useful technique. It can be used to identify a compound in a mixture. It can be used to assess the purity of a compound. And most importantly, it's used to monitor or follow the progress of a reaction from starting materials to products. The essential gear for thin layer chromatography is so-called TLC plates, which we'll use. We have the developing chamber here, which contains our solvent. We have our spotters, which are thin capillaries that we use to spot the compounds onto the plates. We have a pair of tweezers here that we use to put the plates in the chamber. And we, at the beginning anyway, we draw a line, a pencil line, onto the TLC plate to show where the TLC started and finished. So we have a pencil here and a ruler to draw a straight line on the TLC plate. At the end, we will visualize our TLC plate with a UV light. So that's what this is for. There is always the question of the choice of solvent. So we have here ethyl acetate and hexane and a graduated cylinder, and we will mix these solvents to a certain ratio, which we'll have to find out which is best for separating the compounds. So, number one step is actually to prepare the samples. So I'll briefly describe how we prepare these samples. Today, one of our samples is a liquid and the other sample is a solid. For the liquid, we only need 1 drop of the liquid. And so we'll take that with a pipette. We will add 1 drop to a vial. And then, with this vial, we want to dissolve the liquid into a suitable solvent, and ethyl acetate is a good choice for this. So we'll put a squirt or a milliliter of solvent, ethyl acetate, and dissolve that sample. And I will label that as sample A. The second sample, the solid, will be sample B. We only need a small bit of the sample. Well, this much, hardly see it. We will add that to the vial. And we will dissolve that in a pipette full of ethyl acetate. Now this sample is not that soluble in ethyl acetate, so sometimes you have to heat it. To do that, it's convenient to have a heat gun handy, and we will just heat it like so. And now it's dissolved. Now, TLC preparation, we grab a plate, making sure we don't put our fingers on the silica gel side of the plate. There's a glass side and a silica side. To prepare the TLC plate, we will put a faint pencil line about 3/4 of a centimeter up from the bottom of the plate. Like so. Then we put our plate down in the fume hood. We take a spotter and make sure that the end is broken off flat, and we will stick this into solution A, and we will give it a little dab right on the pencil line on the left, like so. We'll tap it once, and then we will tap it a second time, and you can see that the solvent is evaporating. The rest of the solvent from the TLC plate you can run out onto some paper. Now before we use the same pipette in sample B, we break off the little bit that was at the bottom. When we break the tip off, so that we have a clean pipette to go into the next sample, we'll put the broken piece onto a watch glass for disposal into the broken glass. And being careful not to poke it into our finger, and we'll get a sample of the second sample, B, in the spotter. and spot that just to the right of the first bit on the line. That should be good. Now we are ready to put our developing solvent into the TLC chamber. Generally, one has a mixture of approximately 1:1 ethyl acetate hexane, depending on the polarity of the compound we're looking at. It turns out that the two compounds we're looking at, we're going to put straight hexane into the developing chamber. So we just need to put about 2 milliliters enough to cover the bottom. Put the top on upside down and just swirl it around so that the atmosphere inside the chamber is saturated with the solvent. Then we grab our spotted TLC plate with our tweezers and put it into the chamber towards the back and let it lean towards the back of the chamber and put the lid on. And when the solvent has come up, within half a centimeter of the top of the plate, you can remove the plate from the chamber and very quickly, with a pencil, just mark a line as to how far the solvent went up. This is called the solvent front. The solvent evaporates from the silica gel on the front, and now we're ready to visualize where our spots are. And to do that, we will just put our plate down here, and we bring our UV light over, turn the light off and the fume hood is desirable, and we show it, and there are our two spots. So the left-hand spot, the tetralone was non-polar, it went a little farther up, and the right-hand spot was 2-naphthol, and it is a little lower down. It is convenient to take your pencil and just circle the spots like so, so we have a memory of where the spots have gone. This is a UV light and you want to avoid shining it on your skin as much as possible. We now calculate an RF for the spot, which is the distance from the bottom line to the spot, which in this case is 2 centimeters, divided by the distance from the bottom to the solvent front, which is 3.5 centimeters. So 2 divided by 3.5 is equal to 0.57 for spot B. For spot A, the spot is up approximately 2.5 centimeters. So spot A is 2.5 divided by 3.5, which is equal to 0.7. So the RF for A is 0.7, the RF for B is 0.57. It's an indication of how far up the plate the spots traveled.